Hello, my dear students. My name is Lakshmi Narayana. This is LN brand of chemistry. Today we are going to discuss about in the Tatomerism. The previous we are discussed one of the topic that is class 11 Tatomerism, video number 4. So in that continuation for this, it is a continuation for the fourth video. So you have to observe that what we are going to discuss in it. So here percentage of phenol content and stability of enol. What factors are affecting on the stability of enols that we have to discuss. So in the previous topic we are discussing about the tatomerism. What is the tatomerism? Tatomerism means what we are discussing. So here same molecular formula, molecules containing same molecular formula, but sir, here oscillation of hydrogen atom from different polyvalent atoms. For example, sir, CH3, then C double bond O, then CH3, like this will be there. Then it will be converted into CH3, CH2, double bond C, bond OH, bond CH3, like this will be there. See, look at, sir, what happens there. Sir, here 1, 2, 3. Then from, sir, here to here, sir, from one position to third position, hydrogen atom is migrated. Molecular formula is same, but hydrogen atom is migrated from the carbon atom to oxygen atom. Nothing but different polyvalent atoms. Okay, whatever. Sir, you have to know one of the thing that is, sir, ketone. So this is ketone. Then here ene, sir, CH2 double bond C ene, then OH is there all. This we are calling ketoenol tatomerism. Ketoenol tatomerism. Sir, okay, in the ketoenol tatomerism, sir, which is the more stable? Definitely ketone is the more stable. Keto compound is more stable than enol compound. So this is maximum case. Sir, how much case? So 99.99% case, this is more stable. No doubt at all. But some other cases, that is 0.00025% of phenol, also stability. Some of the compounds depends upon some factors. Enol also is more stable. Sir, what are those that we have to discuss now? Sir, what I told, sir, first ketonic group is more stable, no doubt at all. But enol also stable due to some factors. What are those of that factors that we have to discuss? Clear? Right. So, tatomerism nothing but what we are discussing. Tatomerism nothing but tatomerism. Two different compounds having same molecular formula, but hydrogen atom oscillate from carbon atom to oxygen atom. For example, CH3, C double bond O, CH3. This is the ketonic group. CH3, C double bond O, CH3, ketonic group. Right. Sir, what I told, the hydrogen atom will be transferred from this position to this position. So look at 1, 2, 3, third position. See, this atom how it is, CH2 double bond C, bond OH, bond CH3. Sir, hydrogen atom carbon పై నుంచి oxygen atom కి shift అయింది, migrate అయింది. So then we call So now this compound we call enol. Enol. I told that ketone is a 99.99%. Sir, enol it is a 0.00025% will be present. Sir, what is that? Stability. Stability. So maximum case ketonic group is more stable than that of enol formation. Enol formation. So now some of the percentage of phenol compounds also stable. At what reasons these are stable? That we have to discuss. So stability of phenols. Stability of enols depends on some factors. What are those? Number one, aromaticity. Sir, wherever the aromaticity is possible, at that case, enol is more stable. Sir, what is the aromaticity? Then that compound must be contained cyclic అయి ఉండాలి. Then conjugation లో ఉండాలి. Then ప్లానార్ కాంపౌండ్ అయి ఉండాలి. సరే ఇవన్నీ ఫాలో అవుతూ సరే మళ్ళీ 4n + 2π ఎలక్ట్రాన్స్ ఉండాలి. 4n + 2π ఎలక్ట్రాన్స్ ఉండాలి. సో దెన్ వి కాల్ ఇట్ ఇస్ అరోమాటిసిటీ. సో అరోమాటిసిటీ పాసిబుల్ అయ్యే ఛాన్స్ ఉంటే so that enol content is more stable than that of ketonic formation. That's what I have to discuss. Next, second I told the hydrogen bonding. Sir, wherever the hydrogen bonding is possible, even that case also is more stable when comparative to aromaticity is less stable. The next third one, conjugation also more stable. Conjugation also is more stable. So next one more factor will be effect on it, that is depends upon the solvent also. అంటే ఈ మాలిక్యూల్ ఏ సాల్వెంట్ లో ఉంది అనే దాని మీద కూడా డిపెండ్ అయి ఉంటుంది ఇనాల్ కంటెంట్ ఫార్మేషన్. సో వాట్ ఎవర్ ఇట్ మే బి, దీస్ ఆర్ ద మోస్ట్ ఇంపార్టెంట్ వన్. Sir, what I told, these factors are affecting on the stability of phenols. So now some of the compounds we'll discuss, sir, which is greater enol content formation, that we have to discuss. Clear? Right. See, sir, 3 compounds are given. Sir, in that 3 compounds, which is more stable enol content? They are asking question. More stable enol content. For example, CH3, C double bond O CH3. Then one more, CH2 double bond CH, C double bond O CH3. Then one more, benzene attached with, then C double bond O CH3. All these are ketonic formations, right? Which are the following compound can form higher formation of phenol content, higher percentage of phenol content? They're asking question. Sir, write or otherwise write the order of percentage of enol formation of following compounds. Look at, so first question we are taking, first option we are taking. Sir, we are seen like this, then CH2 double bond C bond OH, then bond CH3, like this will be there. Sir, enol content in case if it is more stable, that is more percentage of phenol formation takes place. Sir, here more percentage of phenol formation should be takes place. Some rules I told. One is aromaticity undali leda, hydrogen bonding possible avvali leda, conjugation aina undali. Sir, all these are possible in it. So aromaticity not possible in it. Sir, of course, in the conjugation is the double bond, single bond, lone pair of electrons conjugation. But, sir, here electron releasing group is there. Electron releasing group. Sir, electron releasing group decreases the conjugation. Electron releasing group, what happening there? Electron releasing group decreases conjugation. So conjugation decrease chesta undi electron releasing group. So that's what it is, a less stable content. Next, if you come to there, CH2, already double bond is there here, CH, then bond C, so double bond CH2, bond OH, like this will be there. So in case if it is there like this, so more conjugation will be observed, you can observe that. So pi bond, then sigma bond, then pi bond, or otherwise. So then lone pair of electrons, sigma bond, pi bond, lone pair of electrons, sigma bond, pi bond, like this. So conjugation is there. But for this conjugation, there is no electron releasing groups like this, CH3 or something, any releasing group. So if you come to there, then you can write the enol content like this. You can write enol content like this. How? COH, double bond CH2. Double bond CH2. This double bond is conjugation with a aromatic ring like this. So more conjugation will be there. Aromatic compound is there, that will be involved in the more conjugation. So enol percentage is greater for this. So 99% it will be formed. Then after this is more stable. Then after this. So C is a more stable than that of B, than that of A. So this is the percentage of phenol formation of order of these compounds. Clear all of you? So now some other compounds will see, sir, how which type of compounds can form more content of enol formation than that of ketone. Ketone kante enol lo ekkada formation ekku untundi danni observe cheyali. So look at now some other compounds we are observing, that is sir, one is sir benzene, like this will be there. So double bond both are there. Then double bond O is there like this. Sir, observe it, 1, 2, 3 positions will be there. Sir, hydrogen atom can be migrate from first position to third position. Then enol formation takes place. By forming enol, here aromaticity also forms. Aromatic compound it is. Aromatic compound. So how can you say the aromatic compound? I told you that follow rules, aromaticity rules. One is cyclic. Yes, is that cyclic or not? Yes. Second one, conjugation. All the pi bonds conjugation lo unnaya leda? Yes, conjugation. Then third one, planar. All carbon atoms are present in the sp2 hybridization. So trigonal planar. So all are planar. Then next, fourth one also I told, that is 4n plus 2 pi electrons will be present. 4n plus 2 pi electrons also present. How it is? Sir, in case n value is 1, sir, n value equals to 1, then how many electrons? 4 plus 2, then 6 electrons. 6 pi electrons is there or not? 6 pi electrons is there or not? Yes, 6 pi electrons. So look at 1, 2, 3. 3 pi bonds, each bond possesses 2 electrons, total 6 electrons. Okay, clear. So now it is more stable enol content formation. Almost nearly 100% more stable. This is a chance. That's what I told. Then one more compound I will tell, that is, so double bond O here, then double bond O here, then double bond O here, right? So double bond O, double bond O. So look at from here, 1, 2, 3, 1, 2, 3, then 1, 2, 3. So hydrogen, it can be migrate. So look at one position to third position. one position to third position. In case hydrogen atom, here two hydrogen atoms, you can observe that two hydrogen atoms are there. One of the hydrogen atom can be migrate from here to there. So how it is migrate? This bond, when it is shifted to there, this bond will be shifted to there, then hydrogen atom will come through there. So that OH will be formed here. So this bond, it will come as a double bond there. Then the same thing even here also it happens. Then so from here onwards it will go. So double bond, then OH will be formed. Then even here also, where this case, so two hydrogen atoms are there, hydrogen atoms. So one of the hydrogen atom will be shifted to there. Then here already double bond is there. So that will be shifted, then OH like this. So that means even here also double bond will be formed. Double bond will be formed. So OH also formed. See, look at aromaticity. I told you, so there are some factors. One is aromaticity follow అవ్వచ్చు, లేదా కాంజుగేషన్ ఉండొచ్చు, లేదా హైడ్రోజన్ బాండింగ్ ఉండొచ్చు, లేదా సాల్వెంట్ ఎఫెక్ట్ కూడా ఉండొచ్చు. సో వాట్ ఎవర్ ఇట్ మే బి. నౌ వీఆర్ డిస్కసింగ్ ద అరోమాటిసిటీ, రైట్? సో అరోమాటిసిటీ ఉంటే దెన్ ఇట్ ఈస్ ఈనాల్ ఫార్మేషన్ 100% రిప్రజెంట్ చేస్తూ ఉంది. ఈనాల్ పర్సెంట్ ఇస్ గ్రేటర్ దెన్ దట్ ఆఫ్ కీటోన్. కీటోన్ కంటే కూడా ఈనాల్ పర్సెంటేజ్ ఇస్ గ్రేటర్. Okay, third one more compound we have seen. So that is, so like this will be there. So here double bond O, then even here double bond O is there. Okay, then 1, 2, 3. So first position nunchi third position ki hydrogen atom migrate avutundi. That is called tatomerism. We are seen, right? So even here also 1, 2, 3. So first position nunchi third position ki hydrogen atom migrate avutundi. Sir ikkada migrate అయితే సరే ఎలా ఫామ్ అవుతుంది చూడండి, ఎలా ఫామ్ అవుతుంది. సార్ ఐ టోల్డ్ యూ నో, సార్ వన్ ఆఫ్ ద హైడ్రోజన్ ఆటమ్ బాండ్ విల్ బి షిఫ్ట్ హియర్, ఎస్ డబుల్ బాండ్, దెన్ బాండ్ విల్ బి షిఫ్ట్ టు దేర్, ఎస్ O minus, then where O minus is there, H will be transferred to there, yes H will be transferred like this. Even here also same thing happens, sir O H, sir O H like this. Sir here actually there is no aromaticity not there, but conjugation will be there. You can observe that pi, sigma, pi, conjugation will be there. Even pi, sigma, lone pair of electrons, conjugation will be there, right? Then one more you can observe that, sir, hydrogen bonding in between them, hydrogen bonding also present. Hydrogen bonding, then conjugation, both are present. So that when comparative to ketone, then enol formation is 100% it will be formed. So this is enol formation, this is ketonic formation. Why ketonic formation is less percentage than the term? Here what reasons I told, hydrogen bonding undi, conjugation undi. Then one more factor also is there, sir, when ketone attached beside with each other, sir, here this is electronegative, this is electronegative, more repulsions are possible. So that's what ketone is very less stable than that of enol. So enol is more stable in this. Clear, my dear students? So some other compounds will see, that is in which enol formation is greater, than that of ketone. Ketone kante ఏ enol formation greater, అంటే ఒక ketone compound more than one enol formation ను రిప్రజెంట్ చేస్తే సరే ఏ enol ఇందులో మోర్ స్టేబుల్ అని. సార్ ఫర్ ఎగ్జాంపుల్ నేను కాంపౌండ్ తీసుకుంటా ఉన్నా, దట్ ఈస్ benzene attached with C double bond O, C double bond O, then CH2, bond C double bond O, again benzene is attached to there. Again benzene is attached to there. Like this will be there. So now in case 1 comma 3 shifting, 1 comma 3 migration, what I told 1 2 3 migration. So hydrogen akkadiki migrate aithe, right? Double bond double bond double bond, then COH double bond CH, bond C double bond O, then again benzene will be there. Sir, one more also possible. So that is sir, in case one more hydrogen atom when it is shifted to there, 1 2 3 3 migration, then CH COH, then double bond CH, H will be migrate from there to here, right? From here to there, then C double bond C, then bond OH, then look at like this will be there. Sir, observe it. Sir, here two double bonds beside with each other will be there, so that it is unstable compound, unstable. So this is not stable. Sir, if you observe that, so this double bond is conjugation with aromatic ring to conjugation. And as well as, sir, here lone pairs are there, lone pair sigma bond, pi bond, then again sigma bond, pi bond. So conjugation, continuous conjugation will be there. And as well as we have to observe that, sir, here hydrogen atom is hydrogen bonding with this oxygen atom. Sir, ఏముంది hydrogen bonding ఉంది. So hydrogen bonding also possible, even conjugation also possible. So this is 99% more stable enol than that of this is. Understand? Yes. Then one more compound, will see. One more compound, my dear students. So that is second one. Benzene will be attached to that. Then C double bond O, then CH2, then C double bond O, then CH3, like this will be there. Sir, here such many possibilities are there for the shifting of hydrogen atom from here to 1 2 3 position. Look at first. Okay, enol formation. ఎలా ఫామ్ అవుతా ఉంది, ఇది OH గా కన్వర్ట్ అయింది, దెన్ డబుల్ బాండ్ CH, దెన్ బాండ్ C double bond O, then CH3 is there, right? Then second one, look at, sir, in case hydrogen atom when it is shifted to only from the here onwards, then benzene as usual, then C OH double bond is there, then from here to there 1 2 3 position, sir, ikkada nunchi ikkada, then C double bond C, then OH, bond CH3 is there. Then one more is possible from here to there, 1 2 3. So third one, C OH double bond C, bond H, then CHOH, bond CH3, like this will be there. Okay, clear? Right. Sir, one more possibility is there, that is C double bond O as usual will be there, then from here onwards, then CH, then double bond C OH, then bond CH3, like this will be there. So like this is the fourth compound. So which is the more stable enol in these four enols? So we have to observe that. Sir, one thing you have to observe each and every molecule, each and every enol molecule. One is electron releasing group is there. This is electron releasing group. Electron releasing group. Electron releasing group. Sir, here, of course, here also electron releasing group is there. Sir, one case, in case if you take, then CH, then here, sorry, CH2 double bond. So like this will be there. Sir, observe all these things. Sir, the which case is more stable? Sir, this fourth case is more stable. The total fourth case. Sir, how it is fourth case is more stable? 87% is more stable. Yenduku, what reasons is the most stable? So look at, this is there, pi bond, sigma bond, pi bond, then sigma bond, then lone pair of electrons, all are in the conjugation. Conjugation is there. Then hydrogen bonding also is present. Hydrogen bonding also is present. Okay. Then if you observe that, sir, one more, if you observe that, this is, then sigma bond, lone pairs, sigma bond, pi bond, sigma bond, then here sigma bond, then pi bond. Sir, conjugation undi, hydrogen bonding undi. Sir, ikkada conjugation undi, hydrogen bonding undi. Sir, here electron withdrawing group is attached, then stabilize the conjugation. Of course, even here also attached, but here, then sigma bond and sigma bond, both when it is shifted to there or when it is shifted to there. So here, electron releasing group also is there. Electron releasing groups decreases the stability. So that's what it is a more stable when compared to this. Then third case, in case if you take, sir, phenyl group is there, then COH double bond CH bond COH double bond CH2 will be there. Sir, conjugation is there or not? We have to check it once. Sir, pi bond lone pair of electrons, so sigma bond, pi bond, sigma bond, then here sigma bond again, in case if it is go. So again here pi bond is there, like this. Okay, right. So this is the more stable enol formation. Clear? Next, one more compound we'll see. Next, one more compound on this, you have to see. One more compound, my dear students. So that is H, C double bond O, CH2, C double bond O, H, like this will be there. Sir, write enol content. Sir, 1, 2, 3, third position. Sir, H will be migrate from there to here. Sir, H, C, OH, then double bond CH, then bond C double bond OH. Sir, here this is most percentage of enol content. Why? What is the reason? Because a lone pair of electrons, sigma pi bond, so and hyperconjugation also is present, conjugation also is present, conjugation present ayindi, hydrogen bonding also present, so ketone kante enol formation more stable. Sir, enta percentage more stable? Sir, 100% is more stable, almost 100% is more stable. Then one more is there, that is CH3, C double bond O, CH2, then C double bond O, CH3. Look at my dear students. Sir, here, so two are electron releasing groups are there. Electron releasing groups. Even here also, electron releasing groups are there. Sir, if you write the enol content in it, sir, for example, CH3, then COH, then double bond CH, bond C double bond O, CH3. Sir, if you observe in this phenol, sir, actually sigma lone pair of electrons, pi bond, sigma, then pi bond is there. So indulo kuda conjugation undi, conjugation is there, and as well as hydrogen bonding is there, but what reasons it is unstable? Because of electron releasing groups are attached. I told you, electron releasing groups decreases the stability of enol. Why? What is the reason? Decreases the conjugation ను decrease చేస్తా ఉన్నాయి. That is the reason. Clear, my dear students? So next one more, that is CH3. Next one CH3, C double bond O, then CH2, then C double bond O, then OC2H5, like this will be there. So now in case if you write enol formation for this, then CH3, then C double bond O, then C migrate, it will be migrate from here to here. 1, 2, 3 hydrogen atom will be migrate. Then double bond CH, bond C double bond O, bond OCH3, like this will be there. OCH3. So now here one of the problem will be there. So lone pair of electrons is a more effective electron releasing group. Even here also electron releasing group is there. So that's what, sir, here stability decreases enol formation. Even here also stability decreases. So remember, my dear students, here the stability only 44% of enol content will be there. Then above case stability, sir, here 76% of enol content will be there. Sir, here only 44% of enol content percentage when comparative to ketone. So ketone is more stable in this case. Clear? Then one more. Right. One more compound we'll see. One more compound. That is then CH3, then C double bond O, then CH bond CH3, then C double bond O, then CH3 will be there like this. Sir, even here also you can write the enol content, that is CH3, then COH, then double bond C, bond CH3 as usual will be there. Sir, ekkadi nunchi hydrogen migrate ayindi, 1, 2, 3, third position, 1, 2, 3 position migrate ayindi hydrogen. Then ikkada C double bond O, then CH3 will be there, right? So this is the enol content. So ikkada enol content em chestha undi, electron releasing group, electron releasing group, electron releasing group. Inni electron releasing groups ఉన్నప్పుడు sir automatic గా conjugation ఏమవుతుంది? Conjugation will be decreases. Once conjugation decreases, even stability also decreases. So remember that, my dear students, the stability of this enol is less than that of the ketone. That's what I told. Okay. Next, one more compound like this will be there. So double bond like this will be there. Sir, ikkada enol content ఎలా ఫామ్ అవుతుంది? Sir, 1, 2, 3. Sir, first position నుంచి హైడ్రోజన్ ఆటం ఇక్కడికి మైగ్రేట్ అవుతాం. Sir, మైగ్రేట్ అయిన తర్వాత వచ్చే కాంపౌండ్ ఏదైతే ఉందో, ఉన్నదో, so that is, if you observe here, double bond will come, here OH will come. So this compound is anti-aromatic compound. So It is very unstable compound, so that this percentage of phenol is 0%. It won't form. So this is 100% is stable when that of enol. So this is the percentage of phenol in the different compounds when comparative to ketones. So remember, my dear students, ketone formation is more stable, but in some cases enol formation also more stable. And what factors it will be affect? One is aromaticity, then conjugation, then hydrogen bonding. So last case I told, that is even solvent also it will work. Sir, solvent ఎప్పుడు work అవుతా ఉంది? Sir, one of the compound will discuss based on the solvent. Based on the solvent, how it will be. Sir, polar protic solvents. Polar protic solvents. Then polar aprotic solvents. Aprotic solvents. Aprotic, protic. Protic అంటే ఏంటి? H plus proton రిలీజ్ చేసే solvents. What are those? In case if you take water H2O, it can release H plus, then OH minus. Then in case if you take ethyl alcohol, this can release C2H5, O minus plus H plus. Then in case acetic acid, CH3COOH, it can release CH3COO minus plus H plus. సరే, ఇవన్నీ కూడా ప్రోటిక్ సాల్వెంట్స్ అంటాం జనరల్. ప్రోటిక్ సాల్వెంట్స్. సరే, ఇక్కడ ప్రోటిక్ సాల్వెంట్లో ఉన్నప్పుడు సార్ పర్సెంటేజ్ ఆఫ్ ketone is more stable. Percentage of ketone is more stable. Sir, in case polar aprotic solvents like acetone, CH3, C double bond O, CH3, then DMSO, dimethyl sulfoxide. This one we call DMSO, dimethyl sulfoxide. So this is what we are calling acetone. సరే, ఇవి రెండు సాల్వెంట్స్ కూడా సాల్వెంట్స్ గా వర్క్ అవుతాయి. వీటిని అప్రోటిక్ సాల్వెంట్స్ అంటాం. ఎందుకంటే సో దట్ వోంట్ గివ్ protons. That's what we told. So look at now. Sir, in case CH3, C double bond O, CH3 is there. Then when it is dissociate, CH2 double bond C, OH, then bond CH3. So this is enol formation. Sir, polar aprotic solvents లో enol more stable. Protic solvents లో which is ketone more stable. This is. Thank you, my dear students. Right.